First, in our astronomy unit, we are finally done with the scientific method and the metric system, and we're moving on to Earth science content. So our first unit is astronomy. In this unit, we'll start by looking at our home in space, the Earth. We'll move outwards to the moon, the sun, and then look at the rest of our solar system, and then move beyond our solar system, the stuff that orbits our sun, into what we call interstellar space. So galaxies, black holes, and where did this all come from? But we're going to zoom way back in and start with our little home in space, the Earth. Right, this is a view of the Earth from the moon. It's really tiny from that far away. So let's talk about some important things about the Earth that affect us in our everyday lives. So the first property that we want to talk about is rotation. Right, the Earth rotates, which means it spins on its axis. So it spins around. All right, so rotation is the spin of the Earth on its axis. Alright, and this takes 24 hours. So one rotation equals 24 hours. And as you might imagine, this causes day and night. Alright, as the Earth rotates, we move into the sunlit side of the Earth and then out of the sunlit side of the Earth. Pretty straightforward. The next property that is important is the Earth revolves around the sun. So we have this other property called revolution, which is different than rotation. So revolution is the movement of the Earth around the sun. As you can probably guess, right, other objects also revolve around the sun. Other planets have their own revolution. The moon revolves around the Earth. So revolution is the movement of some object around another object. The path the object takes is called its orbit. So revolution is the actual motion. The path the Earth takes around the sun is called the orbit. So you'll hear those terms used interchangeably, especially if, like on the news and stuff, because people don't really understand the difference in the terms. But orbit is a path. That would be like the track by Baker Field. Like lane 1 would be a particular orbit, right? And then revolution would be you actually running on the path. So the orbit is the path. That would be this purple line in this picture would be the orbit. Revolution is the Earth actually moving on that. And it takes one revolution, takes 365 and a quarter days, which is 1 year. Right? And every 4 years, right, we don't have quarter days in our calendar, but you'll notice that every 4 years we do add an extra day, and we call it a leap year. And so every 4 years we add an extra day to kind of make up for those quarter days that have been adding up each year that we haven't taken into account. If we didn't do that, the calendar would slowly kind of shift off by a quarter day every year, and that would add up, and eventually we would have summer in December because the calendar would get shifted off from what we normally think of it as. So, kind of cool little fact. Alright, this is where it gets super cool. It turns out the Earth is tilted. We think of the Earth as being kind of straight up and down in space, but the Earth is actually tilted 23 degrees compared to its orbit. So if we think of the orbit as a disk, right, the Earth is not straight up and down relative to that disk. It is on its side a little bit. So instead of being straight up and down, it's tilted. So the Earth is tilted, and we say it's tilted relative to its orbit. Right? Remember, orbit is the path. So it's tilted relative to its path around the sun. And this tilt causes the seasons. Right? So the tilt is always pointed the same way. So it's not that the North Pole is always tilted towards the sun. Here, in this picture, the North Pole is tilted towards the sun, but 6 months later, the Earth will be swing all the way around the back, would be somewhere over here by these green dots, and the North Pole would be tilted away from the sun. All right? And this tilt causes our seasons. So if the North Pole is tilted towards the sun, we get more direct sunlight in the northern hemisphere, and that would give us summer. We'll actually add this in our notes a little bit later on. If the South Pole is tilted towards the sun, the North Pole is going to get less direct sunlight. So Let's take a look at it. This picture shows pretty clearly how this works. So it's not that the Earth wobbles back and forth, right? The Earth stays at a fixed angle. It's not wobbling like a top. You know how when you spin a top, it stays pretty straight for a while, and then as it slows down, it starts to wobble. It doesn't wobble. The Earth is always tilted in the same direction, right? But as we move through our orbit, sometimes the North Pole is tilted towards the Sun, sometimes away. So the tilt always stays the same. And we can say sometimes the North Pole is tilted towards the Sun, sometimes it's tilted away. All right, and let's talk about a couple of these important points in the orbit. So we have solstices are 2 days in the year when either pole is pointed at its maximum amount towards the Sun. So the solstice is a day where either pole is tilted the most towards the Sun. All right? Summer solstice would be when, for us, would be when the northern hemisphere is tilted towards the Sun. So summer solstice in Atlanta is when the North Pole is tilted towards the Sun. Our winter solstice would be when the South Pole is tilted the most towards the Sun. All right. And it's cool, so the cool thing is we get opposite seasons in the southern hemisphere, right? In this picture you can see the sun's rays coming in from the left. The North Pole right up here is tilted a lot towards the Sun. It's getting much more direct sunlight, so it's going to get a lot more heat. Right? Remember, the Earth is still spinning while this is happening. So up here it's going to get a lot more sunlight and a lot more heat. We're going to have longer days, warmer temperatures in the northern hemisphere. But down here in the southern hemisphere, you're going to have shorter days and colder temperatures during the same time of year. So this might be July. We're having summer where South Africa and Australia will be having winter, right? Which is crazy to think about. So Christmas actually occurs in the summer in the southern hemisphere, which is a little weird. Our last term that we need to know are equinoxes. And equinoxes occur when the Sun is directly above the equator. So they are right in between the solstices. So they occur between solstices. And the Sun, neither pole is tilted towards the Sun at all. Tilted towards the Sun. All right. We have a vernal equinox. Is the first day of spring. All right. This is the only one that's a little tricky to remember because it doesn't have the title of the season in it, but that's how I remember it. Vernal. All the other starts of seasons have the name in them. Autumnal equinox, first day of autumn. Summer solstice, first day of summer. Winter solstice, first day of winter. So vernal equinox, the only season we have left is spring. Right? And the autumnal equinox is the first day of autumn. All right, day and night are pretty much equal at these two spots. Right, March 21st, September 23rd. We have about 12 hours of daylight, 12 hours of darkness. So right now, right in October, it's probably somewhere between October 10th and 13th that you're watching this video. Right, we are past September 23rd. We are heading towards the winter solstice. Right, the Earth would be somewhere about here in its orbit. And you'll notice that we get less than 12 hours of daylight right now. Right, we're moving towards our shortest day of the year. All right, so we will go over this in class on Monday and do some hands-on stuff to kind of demonstrate this. I know these are kind of tricky things to picture in your mind, but please write a summary. All right, enjoy your long weekend. Sorry about that. Write a summary, enjoy your long weekend, and I will see you guys next week.